recording. Hello, everyone. You are welcome to today's lesson. Today's lesson is going to be the last lesson on core math word functions. In our previous meeting, we were looking at, I think that was the second meeting, we were considering the solution to past questions or likely exams questions. So today will be the third and the last lesson in dealing with what's solutions to past questions and what's likely exams questions. Okay, in our previous meeting, which was the second meeting for the solution to past questions and likely exams questions and the functions, okay, we ended up at this point. Unfortunately, because of network issues, we couldn't continue. So we are going to continue today since we have a better network. Okay, so good morning, Cadmiel. All right, so now this is what we have. As usual, you know what we did. We said f of x is equal to this. So I've told you, you can see f of x here. So substitute f of x there, which is what you have here. And it's equal to -4 and 3. At this point, you are going to end up getting, an equation and quadratic equation for that matter. But this quadratic equation contains a fraction. And remember, I told you that you clear the fraction and you move everything to one side before you start solving. So after clearing the fraction, we'll get this times 3, which will give us what? 9s squared. This times 3 will give us -15s. This times 3, the 3 will cancel, you get -4. But what do? We are going to take, we know it's a quadratic equation, and every quadratic equation, we have to first of all check whether we can use the method of factorization. So in that case, we have to move this one to the side. So that gives us 9x squared minus 15x, then plus 4 is equal to 0. Is my point well made? Okay, yes. So we need to go and look at, unfortunately, our leading coefficient is not 1, but fortunately, we know how to deal with, this kind, where the leading coefficient is not 1. So you multiply the 9 and the 4. 9 times 4 will give us
30.
Come again.
36.
Okay, 36. So we are going to look for factor pair of 36, which when you add, you get what? 36. And when you, sorry, did I say when you multiply, you get 36. When you add, you get -15. Which factor pair? I am waiting, my professors. Which factor pair?
-12 minus 3.
Okay, so here, because your sum should give us negative, and the product should give you positive, it means both numbers, either both numbers are positive or both numbers must be negative. But if both numbers are positive, you get your result to be positive products anyway, but your sum will not be negative. So it means the only option will be your factor pair, all of them being negative. So that when you multiply, you get a positive result. When you add, you get a negative result. And you said -12 minus 3. So this gives us 9 squared. You use the factors to split this. So -12 what? X. Okay, then minus 3x. Okay, plus 4. Do you agree?
Yes.
Okay, so remember I've told you, don't use bracket to group. It will surprise you. You can imagine the number of times that I've said this. Anytime you are solving quadratic equation, I say this, but some of you still use bracket to group. I don't know why. Okay, so at this particular moment, I cast out that spirit. In the name of Jesus. All right, so this is what we have. You group the first two, factorize 9, and 12. What will be the common factor? 3, right? Numerical factor. Okay, s can also come out. Okay, then we end up getting 3x here, then -4. Okay, this one, -1 can come out, and you'll be end. Okay, the last two will give us 3x minus 4. Okay, the whole of that is equal to 0. Okay, we are good to go. So what do we have? 3x, your complete factorization will be 3x minus 1, into, 3x minus 4. is equal to 0. Don't forget, you are dealing with equations. So throughout your steps, you have to get your equal to. So now you set each of the factors to 0 and you solve. So this is equal to 0, or your connected to is very critical. Some of you are not doing the right and simple instructions. Okay, you are finding it difficult to obey. So, and what do we have? We have 3x will be equal to you move 1. You write it again before you divide. 1 over what? Over 3 over 3. So your x here will be equal to, I will use it to draw my conclusion. So I can hold on. It's not necessary for me to write it here. Then this one, I'll get 3x is equal to 4. Okay, I'll write it again before I divide. 3x is equal to 4 over 3 over 3. So I know that my answer will be 4 on 3, which is improper. So in drawing my conclusion, I'll write therefore x is equal to the proper one, which is 1 over 3, or the improper, which must be changed to its corresponding base numbers. So 1 whole number 1 out of 3. My point well made.
Yes.
Okay, very
Yes.
good. Okay, so that will be it for this particular. So quickly, we move on to, if you don't have any further questions or any questions, let's move on to our next, question, which is question number 7. Okay, so number 7, as usual, solution. That's what we write first. Questions are numbered because we want you to number your solution. And those of you who would want to write a question, though I've told you, it's not necessary to write the questions. Okay, or even if you write a question, don't let me see the question. When you are capturing, I'm only interested in your solution. Okay, so if you want to write a question, then you have to write everything here before you come and solve. You don't write this, then come and write I. Then you give the solution, you give the solution. No, let this be the last time. Okay, those of you who have been doing that will do that. Next time I see that, I will cancel the whole of your work. Okay, and the comment that I will pass, you will not be happy. Okay, because, some of you, I think I have to push you harder before you adapt and do the right thing. Okay, so very good. Okay, I believe, I'm trusting God that you will not push me to that extent for me to equally, react that way. Okay, so what do we have? We extract the functions. Okay, unfortunately, the functions came in the mapping form, but no issues. Fortunately, we know how to extract them in the relation form. So giving f of x is equal to 2 minus s squared. Okay, and here I realize that it won't go there, so I will come down. G of x is equal to 1 over x minus 1. Okay, so these are your two functions. What are we supposed to do with that? I come to I. So you can see that I didn't write evaluate. No, there shouldn't be a question in your solution. So now what am I supposed to evaluate? So I write that one, and I don't write equal to, it's not a step. It's only an information that I'm extracting. So that would be J of what? Minus 1, on 4. Okay, so now your steps will come in equal to. It's an expression, so you start with equal to. At this point, if you still don't know when to use the implication sign and when to use the equal to sign, then it means you are not, adhering to instruction, or you are not detailed. Okay, so now what do we have? Okay, it means J, our function of interest. Wherever we see x in J of x, we substitute minus 1 on 4, and this is our J of x. So what do? We write, 1 over the x there becomes minus 1 on 4. You can choose to put it in brackets and remove the bracket, minus 1, but I am matured. I realize that the brackets will not be necessary. But if you are not matured, like I have advised you, anytime you substitute, put it in brackets. So the next step, this would be equal to, at a point, your long division bar that you have here must be changed to, the division symbol. But at what point did I say you can change the division bar that you have here to the division symbol? Okay, anyone to help? My professors, are you there? Oh, no one.
Yes, please.
Okay, so I'm waiting. Give me your answer.
Sir, please, I'll try.
Okay.
Sir,
What?
please, when you are finding LCM of the denominator.
Okay, not exactly what I'm looking for, but it's in line anyway. There is an exact statement that I want you to make. Okay, Prof. Bishop.
So please, we have two division bar.
Come again. When you have two division bar.
So we have
No,
two division bar.
not exactly. This is the question. I'm saying, at what point do you change? Okay, you can see that on that particular step, you can change the bar to the division symbol, and it will not be costly. Because for some of you, that has been, okay, your problem. Okay, Prof. Bishop, you want to try again?
This yes.
Okay.
The denominator is a fraction.
When
The denominator is a fraction.
only the denominator.
Or the numerator is a fraction.
Okay, so let me see what Paulette has for us, then I will come in. Prof. Paulette.
Sir, please, I think it's when the denominator becomes a single fraction.
Only the denominator. Okay, I put a general statement. Anyway, Prof. Dodu, a good try anyway. None of you is wrong entirely. Hey, Prof. Dodu.
I think it's when both the numerator and the denominators are fractions.
Perfect. Not fraction, but single fractions. You get it? So at the point where
Yes.
you are going to express your numerator and the denominator, both of them, to be single fraction, that's the point that you can change your bar towards the symbol. So it means at this point, okay, if I come and write 1 divided by, okay, -1/4, okay, -1, and I continue, assuming that I will now come and take the LCM here, okay, divided by this. What you have here is not equal to this, because if you are dealing with this, it's now the order of operation. You have to only work on this one and this one before you come and add this or combine with this. So if you write this, you are wrong, because the meaning changes, and I've told you until you put this one in brackets. So anytime you are changing the division bar to the symbol and you realize that either before or after the division symbol, you have more than a term, put them in bracket to maintain the meaning. Otherwise, okay, you are doomed. But I've told you, if you introduce your brackets, you are introducing operation, but the purpose is to remove operation. So here the advice is, okay, let me check my numerator. My numerator is already a fraction, a single, okay, term. Okay, then my denominator, I know, okay, my next step, I can write my denominator as a single fraction. So at that point, I know that before and after my division, okay, sign, I will have a single fraction or just a term. So I take my LCM there, which becomes 4. I hope you are following.
Yes, please.
Okay, then what do we have? 4 will go into 4 how many times? 1 times -1. Okay, then minus, this is over 1. 1 will go into 4 how many times? 4 times 1. So you are going to get 4 here. So in effect, we are going to get 1 divided by -5 on 4. Do you agree?
Yes.
Okay, so take note of the advice I gave you here. Okay, otherwise you are likely to repeat it in the test. And even in the class exercise or so that we back. Okay, some of you marked yourself right after writing this, but when I checked, okay, I did a correction and your total marks reduced. And you were wondering why. Meanwhile, you not marked according to the instruction. That's the more reason why I always go through your marking. Okay, because I can see where the problems are better than you. So now we move on. It will be, okay, it's 1 over any number. And I can draw my conclusion. 1 over any number will be the reciprocal of the number. Is that not it? So instead of going to write 1 times, okay, which some of you write, so let me write anyway, 1 times the reciprocal, and that would be -4 on 5. Okay, please, okay, you can choose not to straight away come and write -4 on 5. But when you are drawing your conclusion, you know, okay, you avoid concluding with this type of fraction, which is an improper fraction, unless otherwise stated. So this will be equal to, okay, minus, oh, this is proper, is that not it? So we conclude with it. It will rather be proper. It is this one, okay, originally, which was improper. So if you invert it to be proper, and that will be your final answer. So as you are smart, we could have drawn our conclusion here. So we could have stated that this one, like I said, is not 1 over any number is the reciprocal. So I can take the step out and draw my conclusion. All correct?
Yes, please.
Okay, so any question before we move on to the II? And you can see that questions are numbered and are equally numbered my solutions.
Yes, please, I have a question.
Okay, yes, I like that.
Can you skip the second step and just write -4 on 4, -5 on 4 straight ahead?
From here to this.
Yes.
Yes, remember I said that if you want to use your calculator, you can use your calculator. Okay.
Okay.
Only that in
Thank you.
core maths, we usually, okay, will tell you to avoid the use of a calculator, okay, I mean frequently, or if possible, okay, because especially when you are dealing with smaller values.
Okay.
Okay, however, there are no issues. Okay, Prof. Laurentia.
Sir, please, the parts that you found the LCM, is it -3 on 4 or -5 on 4?
This one.
Yes, please.
Okay, what do you, oops. Okay, no problem. I forgot that I was using. Okay, but you can follow from the the previous step. So you should know. You want to tell me that my handwriting is not legible, I won't mind you. This is my nice handwriting. I'm using a digital pen. Okay, but look at how. So it will be -1 here. Okay, over, I think it was over 4. So you can see it's -1 -4. So obviously it will be -5. You get it?
Yes,
Okay.
sir.
Prof. Agnes, is your hand still up?
Yes, please.
Okay, hey, go ahead.
Please, I would like you to explain this part.
Which part?
1 out of 4 divided by -1 out of 4 minus 1.
Here. Is it from
Please,
here?
can you hear me?
Yeah, I can hear you. Is it from here? Hello, is it from here? From the first step?
Hello.
I can hear you. Can you hear me? Please, the rest of you, can you hear me?
Yes.
Yes,
Okay,
sir.
so then Agnes, okay, please work on your, okay, if you cannot hear me, then it means it's from your end. Okay, so work on it. If it's from the first step, I'm very sorry I can't go back because every step along the line, I will ask you whether you are okay. So you should have told me from there rather than let me get to the end before. Okay, all right. So yeah, the other one, the person didn't get what I have written here. That's the more reason why I went back. Okay, other than that, I wouldn't, okay, have. So try and get it from the subsequent examples. Otherwise, you wait for the video and you listen again. Okay, so question 8, solution. That's the first thing that you write. But we have to read the question and check if there will be any salient part to underline, no salient part. Okay, so questions are numbered because we equally want you to number your solution. Okay, you've been given 2 functions. These functions, none of them came in the Prof. Leonard.
Sir, sir,
Yes.
please, I wanted to get the question 7 II because I couldn't hear you clearly.
You said you wanted me to.
I wanted to ask whether you did the question 7 II.
Hey, let me
because
check.
I couldn't.
Oh, I didn't do II. It's good. It's good you had my attention drawn to that. Okay, it wasn't intentional. Okay, so let's go back and do it. Okay, so I. Okay, thank you for drawing my attention. I guess the rest of you, that's what you wanted to okay, bring to my attention. So I'm looking for f of 2 over, okay, g of what, 3. Okay, so this is an expression. So I start introducing my steps with equal to. So I need to have f of 2 over g of 3. What is f of 2? I have to go for my function f of x. So that will be 2 minus 2 squared. Okay, that's f of 2 over g of 3. What is g of 3? G of 3 means wherever I see x in g of x, it will be 3. So that will be 1 over, okay, 3 minus 1. Is my point well made? Or I should come again?
Please come again.
Okay, all right. So indirectly, once you know f of s, you know g of s, you know f of anything, g of anything. So if you are asked to find f of 2, you know f of 2 means wherever you see s in f of x, it will be 2. So that will give you 2 minus 2 squared. Do you agree now? And your g of 3 will mean wherever you see 3 in g of x, it is, sorry, whenever you see s in g of x, it is 3. And this is your g of x, 1 over x minus 1. So x is here. So that becomes 1 over your new x is 3 minus 1. So this becomes your f of 2. This becomes your g of 3. So I just did this directly. You get the point? Otherwise, you will come and write, but f of 2 is equal to this, you simplify, and g of 3 is equal to that, you simplify. Okay, then later you come and substitute. That can also be done. Maybe after this, I'll walk you through that. Only that one, you have to be a little careful, especially when you are going to carry out your substitution. So let's do this and see if you are on board now. So this will give us, our numerator will be 2 minus what? 4. Do you agree? Our denominator will be 1 over 3 minus 1, which is what? 2. All correct. So your next step, you realize that this will give you 2 minus 4 will give us minus 2, which is just a term. So I will write minus 2. Then I can now change my division bar to the division symbol. Okay, divided by half because before and after the division sign, after the introduction, I have a term, okay, each on each side. So we are going to get, this will be equal to minus 2, okay, then times what? 2. Okay, so therefore, your f of what? 2 over the g of 3, okay, will be equal to minus 4. All correct.
Yes. Yes.
Okay, now let's look at the alternative approach, the one that I said you will, okay, take some of them out, go and solve, then import your results. Okay, so let's do that one too and see. Let's explore. Okay. If you can, I dealt with everything at a go. Okay, but if you are going to work in parts, this is how you deal with it. So alternatively, alt. Okay, so after extracting your g of, so I, okay, your f of 2 over g of 3. So that will be equal to, okay, so like I said, you take parts. Okay, so but go and find f of 2. Okay, it's equal to wherever you see x in f of x, you put 2 there. So that will be 2 minus 2 squared. Okay, I will simplify. I'll still continue. So 2 minus what? 4. Okay, which will give me minus 2. All correct. And you come and pick the denominator too. So, and g of 3 will mean wherever I see x in g of s, I put 3 there. So it's 1 minus 3 minus 1. So that will give me 1 over what? Over 2. So I've simplified my numerator, denominator. So I'm going to substitute. So where I'm substituting, that's where you have to be careful because some of you will straight away come and write equal to, okay, and carry out your substitution. That is the minus 2 over half. Immediately you come and write equal to here, you can see that, okay, The equal to here will be affected by what you have directly on top. But you are referring to this, which is not directly on top. Okay, so something has interfered. So because something has interfered, anytime you are going to carry out substitution, write it again. So in this case, I'll write I am smart. So at that point, I can even draw my conclusion right therefore there. Okay, those of you who know, you know. Okay, so I can write therefore, then I will go and carry out my substitution. So it will be f of 2 over, okay, g of 3 will be equal to, then I come and substitute. F of 2 gave me -2 over g of 3 gave me 1 over 2. So at this point, you know what to do. Okay, if you like, you can use your calculator and you end up getting your minus what, 4. Afa. So the problem with you splitting, working in parts is that, okay, after working or solving whatever that you have in parts, okay, and you importing the results, okay, write what you have there, which ordinary would have been equal to what you are going to substitute to get. Write it, then carry out your substitution on that side. Here, nothing interferes, so my equal to my equal. So I know that this is equal to this, this is equal to this, this is equal to this, this is equal to that. Okay, and therefore your conclusion. So if my point is well made, let's move on to question number 8. Okay, which I almost started. Okay, we are doing well. Keep it up. All right. Okay, so now let's look at our next, okay, question 8. Obviously, solution is what you write first. You normal your solution because the questions, okay, or the question is normal. So given you extract your two functions, they came in the mapping form, but you are not worried. You extract in the relation form. Okay, and those of you still extracting functions in the mapping form, okay, please take notes and start doing the writing henceforth. Okay, so g of x, okay, will be equal to 2s squared, okay, minus 1. Okay, so at this point now, I come to I. I don't write equal to I write exactly what I am asked to find. Okay, or in this case, I am given. Okay. Okay, so this is it. Okay, obviously you can see an equation because the statement that we have here has equal to in it. So it means if you are introducing your steps, you cannot no longer introduce your steps with equal to, but rather the implication sign, or you can ignore altogether. Afa. So every step on the way, I want you to think before you write. Okay, I want you to think before you write. So now an implication is what we are going to use. Okay, then f of x, you know that is direct. F of x, so you come and substitute x minus what, 2 is equal to g of minus half. Means wherever I see x in g of x, I put minus half there. Okay, so that will give me, I'm coming. Okay, so like I was saying, g of minus half. This time around, what we have here means wherever I see x in g of s, I put minus half there. So this side will be 2 into g of x here to be minus half squared. Okay, because minus 1. Is my point well made? Because g of half means wherever I see s in g of s, I put what? Minus half there, g of minus half. That's the meaning, the squared. So this side will be left intact. So your x minus 2, and anytime you are writing, you write close to the margin. Here, please, you cannot cancel. Always deal with the power. Until the power becomes 1, you cannot cancel, do any cancellation. So deal with the power. If I deal with the power, I'm going to get minus 1 over 2 times minus 1 over 2, which will give me 1 over 4. Or minus 1 squared, which will give me 1 over 2 squared, which will give me 4. Okay, then minus 1. Then at this point, because the power here is 1, we can reduce. So that gives us x. Okay, my professors, are you following? Minus
Yes.
2 is equal to, okay, this will cancel to give us 1 over 2. Okay, then minus 1. So obviously, you know what to do. Okay, I can play smart. Okay, instead of clearing the fraction or even working on this one, if you work on this one, half minus 1 will give you minus half. Is that not it? So mentally, you know that this is minus half. So what do? You are looking for solving for x. Okay, so you are going to move this one to the side, which will give you minus half plus what 2. So it will be 2 minus half, which will give us what 1.5. So in effect, we are going to get 3 on 2. But we cannot conclude with 3 on 2. So we are right there for x is equal to, okay, 1 whole number. Sorry. Okay, so let me clear it rather than dipping. Okay, so 1 whole number. Okay, 1 out of 2. Is my point well made? Okay, and let me quickly chip in this. Remember, I told you, anytime you are dealing with an equation or inequality, your conclusion will be your last statement. So it will always be there for your last statement. So don't come and write therefore, as some of you did in your previous, therefore f of x, okay, is equal to g of, okay, minus 1 on 2 is equal to x is equal to 1. What is that? Okay, I've told you that anytime you are writing, think before you write. Okay, if it is an expression, your conclusion will always be therefore the expression is equal to your results. However, if it's an equation inequality, your conclusion will be therefore your final statement, unless maybe your results, your value that you have there, you need to work on it a little, then you work on it. Otherwise, that is supposed to be the appropriate conclusion. So now that will be it for I. Let's go and look at II. Okay, II, what are we giving? F of x, okay, plus g of x, okay, is equal to 0. So what we are dealing with at this point, let me ask, is it an equation or an expression? Equation or expression, my professors? Hello, it's what?
Equation.
An
It's an
equation.
equation.
So we start with what sign?
Equation.
Implication.
The
Implication
implication
sign.
sign. Okay, you are doing well. Okay, so now this will give me, okay, this implies, or I can ignore. Okay, what is my f of x? So I go and substitute. F of x is what? Is x minus what? 2. Then plus your g of s. What is your g of s? G of x is what? 2s squared, okay, minus 1. And this we are told is equal to 0. All correct? So the first one resulted in a linear equation, but you can see that the second equation after our substitution, we can obviously see a quadratic equation. Okay, so basically it will mean a little more work. Okay, so like I said, for you to play it safe, you will put it in brackets. Okay, I know the bracket will not be necessary because the coefficient is positive 1. The coefficient is also positive 1. So I can ignore the brackets in each case. So in this case, I will rearrange and combine like terms. So 2s squared, okay, then what? Okay, plus x minus 3 is equal to 0. So I check if I can factorize. So I have to look for the product of 2 and minus 3, and that will give me minus 6. I'm looking for the factor pair of minuses, which when I multiply, I will get minuses, but when I add, I will get the coefficient here of the x, which is 1. So I'm waiting. Which factor pair are we supposed to consider? Your future lies from the factors that you are going to go for. Okay, Prof. Henry.
-2 and 3.
-2 and +3. Please, do you all agree?
Yes, please.
Okay, so we will use that one to split the middle term. So 2x squared, okay, then minus 2x, then plus 3x. Okay, this replacing the middle term there, then minus 3 is equal to 0. So at this point, group the first two and factorize. Don't group using bracket, do that mentally. So 2 can come out, x also can come out. So you'll be left with x minus what? 1. Okay, with this one, 3 can come out and you'll be left with x minus 1 as well. So each two sum contains a common factor. So we are going to get 2x plus 3 is equal, okay, into, okay, the next one will give us x minus 1 is equal to 0. So you set each of the factor to 0. So 2x plus 3 is equal to 0, or x minus 1 is equal to 0. So here I can easily solve for x. So I'll come and do this one first before coming to this. Minus 3. I write it again before I divide. Minus 3. And some of you, you've not been heeding to the advice here where you need to draw it. I mean, write it again before you divide. So I can draw my conclusion at this point. Therefore, okay, s is equal to the value here. I will change it to mixed numbers because this will give me s is equal to minus 3 on 2. Okay, which will give me minus 1 whole number 1 on 2, or okay, 1. All correct. Is my point well made, my professors? Are you following?
Yes.
Okay, so I guess, okay, you are indeed with me. So that will be it for the question number 8. We are going to look at that of what? Of the 9. Okay, we have about 3 more or 4. Okay, so to go. Okay, so let's look at this. Then after this, maybe we'll go for our water break. Okay, so now what do we have? We are going to solution. So quickly, okay, question numbered. So solution must be numbered. You extract the function. They came in the mapping form, but don't worry. Okay, we know how to extract. Okay, so f of x is equal to s squared over 4 minus 9, not a pretty function, but don't worry. And okay, g of x, you are told is equal to what? 1 over 2x. But what's the condition? X not equal to what? 0. Okay, that's what we have. Okay, now, A, we need to evaluate. So what are we supposed to evaluate? F of 4, okay, plus what? J of what? Minus 1 on 3. Okay, what are we are dealing with? Okay, we are evaluating. Is it an expression, an equation, or an inequality? My professors, because that will inform us as to, okay, the symbol that we have to use to, or the operation that we have to use to introduce our steps, not operation per se, but the symbol.
It is an inequality.
It is an inequality.
Yes.
Okay, who was that? Let me see, who was that?
Please, Mamiya.
Mamiya, okay. Okay, so at this point, Mamiya, I will ask you to go and take your breakfast. You need it. Okay, so that's just by the way. Okay, if it's an inequality, you have to see an inequality sign in it. Do you see any inequality sign? So that's why I said, don't just write. The same thing like, don't just talk. I've told you that anytime you give an answer, or you even ask a question that I think you could have done better, okay, I will pull your leg small. Okay, you don't see any inequality sign here. So how do you talk about inequality? And obviously, you cannot talk about equation here because you don't see the equal to sign there. So it cannot be an equation. So obviously, what we have here is an expression. Mamiya, is it clear?
Yes.
Okay, so next time I will come to you again to convince me if indeed your yes is yes. So now I think we all know that this is an expression. And for expressions, we introduce our steps with equal to. Okay, so f of 4. Once you know f of s, you know f of anything. So f of 4 means wherever you see s in f of s, you put 4 there. So I'm going to get 4 squared over 4. Okay, but that's not all, minus 9. That is my f of 4. If you like, you know that f of 4 would be 4 squared over 4, then minus 9, because that is f of x. So f of 4 we know will be equal to this. And G of what? Minus 1 on 3. Wherever you see S in G of S becomes minus 1 on 3. So it will be plus. What do? We have, this is 1 over 2. There is X here, and that S becomes minus 1 on 3. All correct?
Yes, please.
Okay, so at this point, indirectly, you can see that you are dealing with order of operation. But take note, okay, this is a function on its own. This is also a function on its own. So if you like I said, anytime you are substituting, okay, put it in bracket for safety reasons. That would have done, okay, so I'm going to put this in bracket. So in this case, I have to come and simplify what I have in bracket here, which will give me, this will cancel one of the 4. So I will get 4 minus 9 there. My professors, are you following? Then plus, this will give me 1 over minus 2 on 3. Do you agree? Okay, so this gives us 4 minus 9 will give us minus 5. Then plus 1 over this will be the negative reciprocal. So that will give me minus 3 on 2. All correct? Or better still, you can use your calculator to find this. It will give you minus 3 on 2. You come and attach. So that will be plus minus 3 on 2, but the minus will overpower the plus. So at this point, again, you can use your calculator to get your final answer. So, okay, let's see. What will your calculator give you? I could have done it mentally though, but please, let's see. What will your calculator give you? Let's go through the LCM approach. Okay, though it's not necessary, you can use your calculator. The LCM will be 2. This is over 1. Okay, so we are going to get 1 will go into 2, 2 times 5, so minus 10. Okay, then minus what? 2 will go into 2, 1 times 3, so 3. So indirectly, we are going to get minus 13 on 2. But we cannot conclude, okay, with an improper fraction. So therefore, F of 4, okay, plus what? Your G of minus 1 on 3 will be equal to the mixed number form of what we have there. And that will give us minus, okay, 6, 6 whole number 1 on what? On 3, on 2. Am I right?
Yes, please.
Okay, Prof. Leonard, your hand is up.
So we wanted to say the answer for the
Okay, the one that I asked. Okay,
yes.
so like I said, you can use your calculator from here to this straight away, then you draw your conclusion. Don't forget. All right, okay. So we should be good to go with that of what? Of the B. Okay, again. Okay, let me see. Give me some few seconds. Okay, so we are going to look at that of the B. Okay, so B, what are we giving? We are giving F, okay, times what? G is equal to what? 2. And you know what F, this is the same as F of S times G of S because we were told that F and G are the functions. Okay, so let me see. Is it, oh, at my age, how could I forget? Is it Mamiama?
Mamiya.
Mamiya, okay, very good. Mamiya, okay, what is this? Is it an equation, an inequality, or an expression?
It is an equation.
Afa. Okay, why?
Because the equal to sign is present.
Okay, that's it, as simple as that. So we start introducing our steps with what? If it's an equation, we introduce our steps with which sign?
An implication.
An implication sign. Oh, no. So don't let the implication sign, the equal to sign, okay, bring you down. So this implies, now what is your f of x? You know, f of x is what? Okay, s squared over 4 minus 9. It's more than a term, so you put it in brackets because it's going to multiply another quantity. Other than that, the meaning can change. And times your g of x. So your g of x, okay, is what? is what we have here, 1. So I'm going to write 1 over 2x. Okay, but we are told that this is equal to what? 2. All correct? Hello, are we fine, my professors? Okay, so on this note, you should know what to do at this point. Okay, come and I can either expand, okay, then, okay, you clear the fraction, or you can write this as a single fraction, then what do you call it? You remove the bracket later, but I'm going to remove the bracket. So what I have here will be this one, each of the terms times this. Okay, and okay, I can always do it. So let me write it just for the purposes of explanation. Otherwise, I would have done that mentally, which you could have. So s squared over 4 times 1 over 2s. Do you agree? Then minus 9 times 1 over 2x is equal to 2. Do you agree? The equation is not pretty at all, but don't worry. Okay, we have all the tools to deal with it. So at this point, you reduce if possible. S can, okay, cancel one of the x. So it's there. Then you can reduce again. So your first term here now becomes x over 8. Okay, then this becomes minus 9 over 2x. And that will be equal to what? 2. All correct?
Yes.
Okay, so at this point,
Please.
this is all that you need to do. Remember I said, okay, you can multiply through by the LCM, which will be the LCM will be 16x. Or you can write this as a single fraction, then you cross multiply. Okay, Prof. Agnes.
Please come again.
From where?
3 the x squared out of 4 times 1 out of 2x.
As for the substitution, you get it.
Yes, please.
Okay, so you know, you have 2 terms multiplying a term. So each of the terms will multiply that. So I remove the bracket by, it will be this one times this, which is what I've written here. Then this one also times this, which is this. But we are told it's equal to 2. So now you come and simplify on this multiplying. I've told you before you multiply, check if you can reduce. So here the x, you have x squared here, you have x here, that will cancel one of the x. So it means this will be left with x over 4 times 1 over 2. So the numerators will multiply. S times 1 will give us x. Then 4 times 2, the denominators also will multiply, will give us 8. So that gives us what we have here. Is it clear now?
Yes, please.
Then it's the same thing here. Here you cannot reduce. So when reduction is not possible, then you multiply. This is 9 over 1. So numerator 9 will multiply the numerator 1 here. So that gives us 9. Then the denominator 1 will multiply the denominator 2x. So that gives us the 2x. And is equal to 2. Afa.
Yes.
So at this point, you know, you clear the fraction, which will be the LCM. So LCM will be the product of the 8 and the 2x. So that will give us what? 16x. Am I right? Okay, Prof. Lisbeth.
Mr. Hoffman, please, the LCM, please, isn't it 8x?
Okay, very good. So you can see that if you multiply, because 2 is a factor of this, okay, if you multiply straight away, what you will get will be a CM, but not a LCM. It will be a common multiple. So once you don't pick the LCM, then it means you have to do reduction later. You get the point? So
Yes,
the
please.
LCM will rather be, because 2 is a factor of what? Okay, of 8. Okay, we'll use 8 as what? The numerical factor. So it will be 8 times your variable, okay, x here. So it will be 8x. So we multiply by 8x. However, if you, okay, don't know that and multiply this and get what 16x, you end up getting the same result. Only that you will be dealing with bigger values, which you reduce anyway. Is my point well made?
Yes, please.
Okay, so at this point, we are going to multiply through. And because one side contains more than a term, we can do the multiplication mentally. But for the purposes of explanation and for everyone to get it, I will show the multiplication. So it will be 8x, okay, times, okay, x on 8, okay, minus what? 8x times what? 9 on 2x is equal to, okay, 2 times 8x, or 8x times what? Times 2. So here, you know, okay, the 8 will cancel this. So we end up getting s times x. Okay, that will give us s squared. Is that clear? Let me do the cancellation well. It seems I've canceled, okay, the x as well. That's how it's looking. So let me bring out the picture better. So this is what we have. Then this one, the x will cancel this x. The 2 will go here 4. So it means we have 4 times 9. So it will be minus what? 36. Am I right? Okay, and that should be equal to 2 times 8. Okay, 16. Okay, x. Afa. So obviously we are confronted. Okay, let me see whether the next page, okay, there is room there, or it's a different question. It's a different question. So I'm going to squeeze the continuation here. And please, if this happens to you and you want to squeeze the continuation, rule a line. Immediately you rule a line, we'll consider that as your next page. But if there is no line there, then all that will be written here will be considered as your rough work. So in that case, I have a quadratic equation. In order to solve, I have to move everything to one side. But the term here is positive, my s squared term. So I will move everything to the side, followed by the s term, which will be moved here to give you minus 16x. Okay, then minus what? Your 36 is equal to 0. So you come and solve for this. You look for factor pair of what? Minus 36, because the leading coefficient is 1. Then you continue, then you solve. So you should be able to solve this. So you continue for me. Is that clear? Okay, so whilst we are going for our water break, okay, you continue. When you come back, you tell me, okay, the answers that you had. Okay, we'll conclude with those answers. Thank you. So you are welcome back from the water break. Hey, please, Prof. Bishop, what did you get?
Please, I want to say my answer.
Yes, that's what I'm asking. What did you get?
I got x equals negative 18.
X equals what? Negative
2 or 18.
Or?
Positive 18.
Oh, I didn't get the second part.
So please, I got x equals negative 2 or positive 18.
Positive 18.
Yes, please.
Okay, please. Who had a different result? Okay, so you all had this result. And as for your final answer values, you shouldn't get it wrong, because you know how to use your calculators to get your answer. So you can use your calculator to verify the validity, okay, of what or confirm the true nature of your values that you have here. So in this case, I will draw my conclusions. I'll write therefore here. Okay, I am done. And that will be it for the solution to this question. You were asked to solve for x, so you've solved for x. Okay, and if you are asked to find the value of x, don't conclude by saying, therefore, the value of x. No, just write, therefore, x then states its value is equal to. I've told you this before. I'm repeating for obvious reasons. Okay, so now question number 10. Okay, quickly. I think question 10, that should rather be, okay, was it not the one that you were giving? This one was the one that you were giving in class to do, right? No, I don't think so.
Yes.
We've done this before. We've done this. You've done, right?
Yes.
Okay, it's familiar. That's the more reason why. So it means we are going to skip. Okay, let me see whether the one that you were giving, let me see whether it is exactly that. No, this one was the assignment. But I don't remember whether that one we did it. Okay. So no issues. Maybe we'll do that as a classwork, then we'll come back together and mark. Okay, so but no issues. So I will skip that. Okay, that particular one. So we'll move on to question number 11. Okay, question number 11. Okay, a little more technicalities involved in this particular, okay, question. So let's see, solution. And I will need your maximum attention here. 11, question number 11. We extract the two functions, okay? They came again in the mapping form, but we know how to extract, okay, that. So giving f of x is equal to, okay, 2x squared minus 1. And your g of x, okay, is equal to 3x plus 2. Okay, now A, what are we supposed to? So we are told we've been given f of x minus 1, then minus 7 is equal to 0. What you are giving, okay, Mabeya, what is it? Okay, relation, equation, inequality.
It's an equation.
Okay, perfect. Okay, so we introduce our steps, okay, with implication sign. So one will be okay. So here we need to go and find f of x minus 1. But we know f of x, so we should know f of anything. Only that this time around, you are evaluating your f as an expression. We are good at that. Remember, we did this in the lesson 1, the evaluation of functions. So here we just have to apply. So wherever we see x in f of x, we put x minus 1 there. So this is your f of x. So we are going to get 2 into x minus 1, which is our new x, by squared, then minus 1. But that's not all. This is it for only f of x minus 1. But remember, in the equation, you have minus 7 there. So you go and write minus 7. Then it's equal to 0. Is my point well made? Or I should come again?
Please come again.
In the come again members. All right. Okay. So this is it. Assuming once you know f of x, if you are asked to find f of x minus 1, you know that that will give you 2 into x minus 1 all squared, then minus 1, because that will give us f of x minus 1. This is now x minus 1. This will also be x minus 1 by squared. You get it now?
Yes, please.
Okay, so what you have here is what is taking the place of this. But you know, it's not only f of x minus 1 that is equal to 0. It is f of x minus 1, then you subtract 7 from it, so minus 7, that is equal to 0. You get it? You get it now?
Yes.
So if you like, you can put the whole of this in brackets, indicating that that's a substitution for only this one. Okay, but I've told you it's not really necessary. So at this point, we go and deal with the power first. So this gives us, remember, we know how to expand a binomial squared. Okay, that gives us x squared minus 2x, okay, plus 1. Okay, then that's only for the expansion of this. You have minus 1, minus 7, so I'll combine that. That will give me minus 8. And that is equal to 0. I will come and remove the bracket. So 2x squared minus 4x, okay, plus 2 minus 8 is equal to 0. Please, I've told you, if you cannot do this mentally like the way we did it here, you know the meaning of x minus 1 squared means x minus 1 multiplying itself again, x minus 1. Go and expand, combine like terms, and come and substitute your results here. It's equally allowed. However, that will be your rough work. You strike it out, but learn to mature. Okay, so this gives us 2x squared minus 4x, okay, then minus what, 6. Okay, it's equal to what, 0. Okay, here, what will you do? Okay, any ideas, any suggestions as to how we are supposed to proceed?
You factorize.
You factorize. Okay, so how would you factorize?
You multiply the minus 6 by the 2, which will give you minus 12.
Okay.
And try to find factors.
All right, that's okay. All right. Please take notes. This is my humble advice once again. I've said this and I'm going to repeat. Before you start solving any equation, check if you can reduce the equation. Remember, I've said this before. And obviously, this equation can be reduced because if you look at, okay, all the coefficients, okay, 2 is a factor. So you can reduce by dividing through by 2. There's an equation, so you can divide through by a constant. It's only expression that you cannot reduce. Okay, I mean, you cannot divide through by a constant. So in this case, what do we have? We are going to get x squared minus what? 2x minus 3 is equal to 0. So that will make your work very easy. So look at, you can see that the equation is now, okay, prettier. You get it? So today, at least, you know, every equation before you start solving, check if you can reduce. Okay, I said this when we were looking at the undefined situation. Okay, so now you consider, you don't have to multiply anything, consider the factors of minus 3, which we need. So let's go. Which factor pair are we going to look at? Minus 3x plus x, okay, minus 3 is equal to 0. Am I right?
Please, I don't understand the part where you said you break down, like
You reduce because you can divide through by 2. 2 is a common factor to all the terms.
okay.
You can reduce all the equations that we solved. Okay, I mean, even today, I'm talking about today, all of them you couldn't reduce. So we had to go and multiply. But if you can reduce before you do check whether you still have to go and multiply.
Okay.
Okay, so any equation before you solve, okay, try to reduce, especially quadratic equations, if possible. So if you are with me, then I think we are good to go here. So x minus 3 here, then
Please,
plus.
I don't it.
You don't get it?
Yeah, the x squared plus 2x minus 3 is equal to 0.
Which one?
The reducing x squared minus 2, yes.
Okay, so 2 is a common factor to all of them. Is that not it?
Yes, please.
So we can divide each term by 2. So this over 2, the 2 will go. This over 2, it will be, the 2 will cancel this to give you minus 2. This over 2 will give you minus 3. You get it?
Yes, please.
So you get it now. So I can move on.
Yes, please.
All right, great.
Sir.
Okay, so yes, please.
Are you also to divide the 0 by the 2 since you are multiplying?
Yes,
all
but
the
that will give you 0. You don't even have to do that. 0 of any number will give you 0. So you don't even struggle, okay, to do that. You get it? Not that I forgot, but we knew and you should know. Okay, all right. Good. Ask questions. Okay, some of these things, I will say something to, okay, drum home a certain point and convince you better. And at that point, you know, next time you won't have, okay, doubts. Okay, so x minus 3 is equal to 0. So you get x plus 1 is equal to 0, or don't forget this connector, very important, x minus 3. If you forget, I will assure you I won't forget to mark you down. Okay, 3. So here I was just asked to, okay, let me see, find the value of x. So I will not draw my conclusion by saying therefore the value of x. No, it will be therefore s is equal to state the values, okay, or 3. Is that clear? Is my point well made, my professors?
Yes, sir.
Okay, very good. So we are left with that of the B, which let me see whether I created another space for it. I don't think so, but I will see what we can do if I have to duplicate it, because, okay, what we are going to do here will be a little involving. I think the space will not be sufficient for it, but let's see. What are we giving? F of minus 1 on 2 times what? G of what? 3. All over. I think this question, I should shelve it and give it to you as part of the test. My spirit tells me so. Okay, minus what? G of 2. Okay, oh, sorry, G of 5. I think I will just explain. I will bring this one in the test. This basically is an order of operation question involving functions. Okay, so I will just give you a hint as to how to deal with it, but I won't solve it together with you. Take notes. You try it on your own. So f of, if you like, just like we did the other one, you can take each of them separately and you go and work it out. If working with everything at a go will be a problem to you. So you come and write, but f of minus half, you go and solve. Find, simplify. G of 3. Okay, simplify. F of 4. Okay, simplify. G of what? 5. Simplify. Then now you come and write therefore. Okay, whatever that you were given here is equal to, you substitute your simplified result for f of minus half times, you know the dot here is times. Okay, you substitute your result for G of 3, which will be a value as well. Okay, all over, you substitute the value of f of 4 minus, you substitute the value of G of 5. Then now you come and work with the numbers that you have there, looking at it in the order of operation situation. Is my point well made?
Yes, please.
Okay, very good. If you say no, you are a suspect. You mean you want me to solve it so that when it comes in the exams, you will do copy and paste. Okay, but I'm not going to solve it. That's how far I can go. Okay, as far as this question is concerned. So now to our last, okay, question. Okay, which will be this. And the relative math students, they will be smiling. Okay, because they have seen a friendly function there. Okay, composite function initially was not part of core maths until recently. Okay, that we started seeing, I think last 3 years or so, seeing questions on composite functions in core maths. So core maths 2, we treat composite function, but not to detail. Okay, so here, this is what we have, solution. The first thing that you write after reading the question and underlining the salient parts, if any. Questions are numbered because we want you to number your solution. So, okay, you write question number 12, solution number 12. Okay, you extract your function. So your functions will be extracted where you have the question number. So pretty functions, eh? Okay, so f of x is equal to x plus 3. Okay, then, and your g of x, very pretty function. Okay, x squared, just a term function. Okay, now okay, what are we giving? You don't write equal to, you just go and write what you are giving. And that is f of what? G into f of x. Okay, so the common students, okay, please take notes. Okay, if you know g of x, you know g of anything. Okay, so what we have here is an expression. So we start with equal to. I should have asked Mamiya this question. Okay, anyway, so in this case, this is what we have. This means wherever you see x in g of x, it is now f of x. Take note. So indirectly, this is what we have. The meaning of this is j. Okay, I think let me write it well. My j is, okay, so j, you feed it with what? F of s. What is your f of x? It is this function, s plus 3. That is the meaning. Okay, my light is off. Okay, quickly let me reorganize, then we'll come and draw the curtains down.